Once again, students, and welcome to this channel. Here we are going to talk about chemistry practical paper. We say that chemistry contains 3 papers. We have paper 1, paper 2, and paper 3. So paper 3, mostly it is practicals. Let's say it's practicals. Then it has got 3 questions. 1, 2, 3. So these questions test specific areas. Question 1 is all about quantitative analysis. Question 2 talks about qualitative analysis of cations and anions. Then the last question talks about qualitative analysis of organic chemistry. This is all about paper 3 chemistry. We only have 3 areas to test: quantitative analysis and qualitative analysis. So when we talk about quantitative analysis, here is where we will involve ourselves in measuring volume, calculating the rate, drawing graphs, calculating molarity, number of moles, volume, mole ratio, and so on. Now, qualitative analysis, here we analyze cations and anions. In the last part of the question, we analyze what we call organic chemistry. In this video, we are going to understand more about qualitative analysis of organic chemistry. Now, before we dive in, students, if you've not subscribed to this channel, subscribe, like, comment, and share. Now, let us begin by looking at qualitative analysis of organic chemistry. Here we talk about qualitative analysis of organic chemistry. Now, students, when we get into exams, there are 3 things that we need to understand. We need to understand what is tested, how it's tested, and what are the expectations of the examiner. You need to know what the examiner will test, how the examiner will test, and what are the expectations of that examiner when it comes to answering the questions. Now, today we want to begin by looking at what is tested. Also, we'll look at how is it tested. Then we'll also look at what is examiner expecting you to write so that you answer. If you miss one of the 3 things, you cannot score. If you know what is tested and you don't know how it is tested, you will not get it. If you know how it is tested and you don't know how the examiner expects you to write your answers, you will not also get it. So students, those are very, very crucial things to understand. Now, let us look at what is tested. When it comes to this case, number 1, they test you about they use, these are the checklists of the reagent. Number 1, we look at checklist of reagents that are used and processes that are used. That is what it is. Number 1, we can use water and ethanol. Number 2, we can use adding bromine water. There's a very big difference between bromine water and water. Water can be distilled water. Then number 3, we also look at burning. Number 4, we will look at using acidified potassium dichromate 6. Using acidified potassium dichromate 6. Then using number 5, acidified potassium manganate 7. Apart from that, we also have a process called esterification. Esterification. Very, very important. Number 7, we have adding magnesium ribbon. Apart from that, we also have number 8, we have test for pH. Test for pH. Then we have adding sodium hydroxide. Adding sodium. Now, dear students, this is what is tested. They test water, if not water, ethanol. Adding bromine water, burning, acidified potassium dichromate, use of acidified potassium manganate. We have esterification process, adding magnesium ribbon. Then we test for pH. Then we also add. These are the only things that are tested. There is no anything that is beyond here. These are the only things that are tested when it comes to question 3 of chemistry. So qualitative analysis of organic chemistry normally appears in question 2 or question 3 of chemistry paper. It carries around 8 marks to 10 marks in chemistry. So if we be able to understand, it is very simple. Now today, we want to learn a way of getting these answers, even without getting into the laboratory room. We will only go in the laboratory room to prove that our answers are correct or not correct. We want to go there and say, it is there or it is not there. When we were sent to the market to buy a loaf of bread, and the loaf of bread is not there, when we come back to bring the response, we say, the bread is not there. You don't say, there is kangumu. You only say, the loaf of bread is not there. So students, we go to the practical room, we go to the laboratory room, to prove if it is there or it is not there. That is very, very important. Now, number 1, we will look at burning of compounds. Burning of organic compounds. So when we talk about burning, it only tests what? Bonds. We have to test for bond. Double bond and triple bond. That is unsaturation. We test for unsaturation. You don't bring here the case of a single bond. When you say anything about a single bond, we will not even mark. We will wrong you before we look at it. So you must be able to use double bond or triple bond. Say that it normally tests for double bond and triple bond. Now, how do you present your answers? You are given a table like this, where we have the observation and the inference. The inference is like an explanation of the observation you make. If you make a wrong observation, you will not give us a good inference. That is wrong. So, for example, when you talk about burning, we say that you say the solid melts and burns with a yellow sooty flame. Or you tell us the solid melts and burns with a blue non-sooty flame. So when it burns with a yellow sooty flame, then it confirms to us that double bond and triple bond is present. But if it burns with a blue non-sooty flame, it confirms to us that double bond and triple bond are absent. Hope that one is very clear. So when you write your response, you say the solid melts. If you don't send the word melts, then you will not get it. Melts and burns with a yellow sooty flame. Then you say that double bond or triple bond present. You say double bond, triple bond present. You say the solid melts and burns with a yellow sooty flame. Double bond, triple bond present. But what if you get the solid melts and burns with a blue non-sooty flame. You say double bond, triple bond, absent. That's how we write our response students. You don't write there single bond present. No, we are only looking for two. We are looking for double bond. We are looking for triple bond. So you don't bring here anything. When you have said that when you go to the market to buy a bread and the bread is not there, you don't say that there is kambumu. You come back and say the bread is not there. So when we go to the laboratory, our intention is to get the two. Whenever you burn, you want to get the two. If your observation is not the way you want it, then it is like this. We cannot have any other observation apart from the two. If it does not burn with a yellow sooty flame, it will burn with a blue non-sooty flame. If it burns with a yellow sooty flame, double bond, triple bond, present. If it burns with a blue non-sooty flame, triple bond, double bond, absent. Hope that one is very clear, students. Burning represents bond. B, burning, bonding. Very, very crucial, very important. So let us continue by looking at another very important point. This is how it is. Let us be able to get it and understand. Moving forward, we want to look at another crucial important concept. We need. Number 2, adding of water and ethanol. Adding water. Stroke ethanol. When I say stroke, it means we can use either water or we can use ethanol. And this confirms for polar compounds and non-polar compounds. So it confirms it confirms. Polar compounds. Here we have our table. The same way we have the observation and the inference. Now students, here we have different observations that we can get when we get there in the laboratory. Observation number 1, say that the solid dissolves in water. It can be the solid or the solution. So we say number 1, solid dissolves in water to form a colorless solution. The solid dissolves in water to form a colorless solution. That means it is a polar compound. It's a polar compound. That is observation number 1 you can get in the laboratory, given water. Then you can say solid does not dissolve. Does not dissolve in water. Then it is a non-polar compound. It's a non-polar compound. There's no any other response apart from the two. We talk about non-polar and polar. The solid that dissolves in water is a polar compound. The solid does not dissolve in water is a non-polar compound. You can also say the solid dissolves in ethanol. Z is a polar compound. It's a non-polar. When it dissolves in ethanol, it is non-polar. When it dissolves in water, it is polar. When it dissolves in ethanol, it is non-polar. When it dissolves in water, it is a polar compound. Now students, they can give you a solution. You say that the solution, a miscible solution is formed with water. So when miscible solution is formed with water, it is polar. Miscible means it mixed to form one uniform layer. Then when a miscible solution is formed with the water, it is non-polar. When miscible solution is formed with ethanol, it is a non-polar compound. Now that's very clear, students. Hope we have get that clear. Now we need to move on and look at esterification. Esterification now. Esterification. Talk about esterification. Here we test compounds known as esters. This is found in organic chemistry 2 in Form 4 topic number 1. We talk about in topic number around the last topic. The last topic of chemistry Form 4, we read what we call esters. Or that is a process called esterification. Esterification. Here when we talk about esterification, what forms esters is when ethanol reacts with ethanoic acid. So when we have ethanol reacting with ethanoic acid, what is formed is called esters. So when we talk about esters, we will only concentrate on ethanol and ethanoic acid, not any other thing. It will be ethanol and ethanoic acid when we talk about esters. Welcome back, students. We say that when ethanol reacts with ethanoic acid, we get what we call esters. So when we talk about esterification, we will only be looking at ethanol and ethanoic acid. Now let us straightforward look at what is expected by the examiner. We have the observation and the inference. Very, very important. Now, here they will tell you that they add some 2 drops of ethanol followed by, maybe they tell you 3 cubic centimeter of ethanol followed by few drops of ethanoic of concentrated sulfuric 6 acid. So the work of concentrated sulfuric 6 acid is to speed up the rate of reaction. So whenever you see ethanol added followed by some 2 drops of sulfuric 6 acid, that tell you that when we use ethanol, we confirm ethanoic acid. When we use ethanoic acid, we confirm ethanol. Now, what is produced here is what we call a pungent smell. Some of us call it a fruity smell. Some call it a sweet smell. Never write sweet smell. Because while in the laboratory we don't test solution. We don't test. It is one of the rules, is one of the laboratory rules, that we don't test anything in the laboratory. So when you tell us that production of a sweet smell, it means you tested that smell. So you say a pungent smell or a fruity smell. But very, very important is to talk about a pleasant smell. So you say that pleasant smell. So when a pleasant smell is produced, we talk about the alkanoic acid present. Because we have used what we call ethanol. When you use ethanol, you confirm ethanoic acid. What if there is no pungent smell? No pleasant smell. No pleasant smell. We say this one is, here we say it is present. Here we say it is absent. You don't say there is another thing that is present. If it is not there, you say absent. If it is there, you say present. That's how we answer practical questions. Now, what if we add ethanoic acid followed by a few drops of sulfuric 6 acid? Then the observation will change. We will say add OH present. That is ethanol. We say add OH present. Then we say add OH absent. Depending on which is used to test. If we use ethanoic acid followed by a few drops of sulfuric acid, it confirms to us that this is present. Now let us look at what we call testing for pH or acidity. You can say alkalinity or acidity. pH. We have what we call universal indicator paper. Okay, pH test. Here we have the observation and the inference. We have the observation, we have the inference. So we talk about observation, we can have the pH of 1, 2, 3. These are what we call strongly acidic, strong acid. So you don't say strong acid, you fail. The examiner expects you to write strongly acidic, weakly acidic, strongly basic, weakly basic. So you don't say strong base, you fail. You say strongly basic, strongly acidic. If it is, for example, let us say, if the pH ranges from, say, 4, 6, 4, 5, 6, then we say it is weakly acidic. If it is 7, we say it is neutral. If it is 8, 9, and 10, then we talk about weakly basic. It is 10 to 14, then we talk about strongly basic. This is very important. You don't say strong base. You don't say, when you write in paper 1 and paper 2, say strong base, weak base. But when it comes to paper 3, for the sake of earning a mark, say strongly basic, weakly basic, neutral. That's how we write the answers. We say that we have 3 ways of identifying the knowledge of an examiner. 1, how it is tested. We say 1, what is tested? 2, how is it tested? 3, what are the expectations of the examiner? Very, very crucial. Now, students, this is how we test it. We compare from the universal indicator chart, where will be given in the laboratory to use so that you identify the pH. Let us move very fast, students. Let us test use of bromine water. Let us use bromine water. Now, what is the essence of bromine water? We say the burning tests for bond. Bromine B tests for bond. So bromine water tests for bonding. Burning also tests for bond. So here, when we write observation, we look at the color of bromine water. Many students fail there. Bromine water is yellow or orange. You only say orange bromine water or yellow bromine water. When you say brown bromine water, you fail terribly. And when you state observation, you state the initial color and the final color. You don't say the colorizes. You say the orange bromine water changes to colorless. You say the yellow bromine water changes to colorless. You don't say the yellow bromine water decolorizes. Where is the final color? We need the final color and the initial color for you to earn the mark. So you say, when we have the observation here, you say number 1, we have the observation, then we have the inference. Very, very important. So we say that yellow, stroke orange. When you write in your exam, don't say stroke orange. If you decide to use yellow, use yellow. If it's orange, use orange. Yellow, orange, bromine, orange, bromine water changes to colorless. Changes to colorless. What does that mean? We say double bond, triple bond is present. But what if, the last observation for this case, what if yellow stroke orange bromine water retains remains orange or remains yellow? Don't say retains, say remains yellow. We need to see the first color and the last color for you to earn the mark. So it means double bond, triple bond is absent. So when you go to the laboratory, you already have the answers. You go there to confirm. If this changing, is it not changing? Don't copy from your friend. Maybe your friend has got a mistake. Then you copy the mistake and transfer the mistake. When you do practical, you do your own work so that you can be able to answer the questions accordingly. So when you use bromine water from the word or bromine, it is for bonds. Burning, it is for bonds. Students, hope that is very clear. Let us move on. Let us talk about use of potassium manganate 7. Use of, that's number 5. Use of potassium manganate 7. Remember, it should be acidified. If it is not acidified, it cannot be used. Say acidified potassium manganate 7. It's acidified potassium manganate 7. The formula is acidified potassium manganate 7. Now, that is very, very important. Now here, this one is used to test for double bond and triple bond, alkanoic acid and ethanol. It tested for all those things. But what is important is the observation and the inference. Very, very important. Observation then inference. Students, say that we look at the color of potassium manganate 7. So the initial color and the final color of the day after the observation, after doing the practical. We say that the purple color, it's normally purple color of potassium manganate 7 changes to colorless. Changes to colorless. In chemistry, we don't say turns to colorless. Turns. To turn means we are turning the paper. We use the word changes. You don't say decolorizes. We say changes to, from to. There we say double bond, triple bond, R or H, present. It tests for all the four. What if the purple color retains, or the purple color remains purple? Then we say these are opposite. That's how we do it. It is very, very simple, students. Now, what is very important here is to master the color of potassium manganate 7 and how it changes to which color. It changes to colorless. Let us also move on to the next thing. Look at dichromate and what dichromate tests for. So you should be able to differentiate potassium manganate 7 and potassium dichromate 6. So potassium dichromate 6. This only tests for R or H. And you need to understand the color. It changes from which color to which color. So, say that observation, we have the observation, then we have the inference. So we say that this manganate dichromate 7 tests only for this. And its color is changes, the color of dichromate changes from orange to green. So if it changes from orange to green, then it confirms that R or H is present. But if it remains orange, then it tells us that this R or H is absent. That's very important. So the difference between dichromate and manganate 7 is that this tests for this and that one tests for the all organic compounds. Now let us move to another very important thing. We are almost coming to the end of these presentations. I would like to ask you to subscribe to this channel to be able to be the first one to get when we upload other lessons. Now here we want to use sodium carbonate, sodium hydrogen carbonate. Now when we use sodium hydrogen carbonate, sodium hydroxide, stroke any metal, a metal can be magnesium, any other metal. Here, remember when a carbonate reacts with an acid, at the end of the day, we get observation, we get bubbles, or which we call effervescence. So we have the observation and the inference. So here, the only observation we target here when we use the 3, we target production of bubbles, production of a gas, production of bubbles. Or if you don't say that, say effervescence. Say effervescence. Effervescence evolves. So when effervescence evolves, then we test for acidity. We test for this, and also test for the 3. We test for these 3. They will be present. These are acidic compounds features. But remember, when they put the stem of the question says an organic compound was used, then only mention these. These are not organic compounds. If we use organic compounds, then ensure that your answer is only ethanoic acid. So production of bubbles or effervescence will show this one. Now students, if there is no bubbles, then it is absent. We've come to the end of this lesson, of this presentation. Be sure you subscribe, to like and share. In our next lesson, we will talk about quantitative analysis of cation and anions. Thank you very much. Let us meet again.